Question 1, find the sum of 337 and 765. So 765 add 337. So 5 add 7 is 12. So we've got 2 extra 1. 6 add 3 is 9. Add the 1 is 10. So 0 extra 1. 7 add 3 is 10. Add the 1 is 11. So 1102. Question 2, find the difference between 9347 and 2985. So 7 take away 5 is 2, 4 take away 8 we can't do, so this becomes a 2. We've got this 4 turning into 14. 14 take away 8 is 6. 2 take away 9 again we can't do, so this becomes 8. This is now 12 take away 9, which is 3. 8 take away 2 is 6. Therefore, this is 6362. Question 3, write 87 to the nearest £5. Now, this is a rounding question. So when we do something to the nearest 10, we think, well, has it crossed the halfway point? Has it crossed something ending in 5? So if this was 87 to the nearest 10, then we could without a doubt say that it's going to be 90. We're deciding, is £87 going to be closer to £85 or to £90? Which multiple of 5 should we go to? And if we look at the difference between 85 and 87, that's a £2 difference. Whereas if we look from £87 to £90, well, that's a £3 difference. So which multiple of 5 are we closer to? We are closer to the £85 because that's only £2 away rather than £90, which is £3 away. So therefore, £87 to the nearest £5 is going to be £85. 4, write 3,284 millimeters in meters. So we've got 3284 millimeters. Now, first of all, let's write what that would be in centimeters. There are 10 millimeters in 1 centimeter, which means if there are 3,284 millimeters we're dealing with, the number of centimeters is going to be 10 times as small as that. So we need to divide 3,284 by 10. That means this equals to 328.4 centimeters. And now that we've got 328.4 centimeters, we now need to take this to meters. So there are 100 centimeters in 1 meter. So if we just have an estimate, we can say that 300 centimeters would be 3 meters. So if we have 328.4 centimeters, we are expecting this to be a little over 3 meters. And therefore, this would be 3.284 meters. So if 328.4 gets 100 times smaller, then it must become 3.284. Therefore, the answer is 3.284 meters. It's really important that we write the units, especially when they don't give them. 5, what is the value of the 6 in the decimal 0.264? So 0.264. Let's just look at the first bit, 0.2. That's saying 0 units, 2 tenths. The next column along is the hundredths. So this has to be 6 hundredths. Then we've got 4 thousandths, because every place value to the right that we're getting 10 times smaller than before. So this represents 0 units. This represents 2 out of 10. This is then 6 out of 100. And this is 4 out of 1,000. Now, this question only really asked us about this part. So we can say that this is 6 hundredths or 0.06. 6, calculate how many seconds there are in 15.5 hours. Well, there are 60 seconds in 1 minute, 60 minutes in 1 hour, meaning that 60 times 60 will give you the total number of seconds in an hour. Well, 60 times 60 is going to give you 3,600 because 6 times 6 is 36. And if you're doing 60 times 60, you've got an extra 2 zeros on the end. So we've got 3,600 seconds in 1 hour. Or in other words, in half an hour, we're going to have half as many seconds. So we can say that we have 1,800 seconds in half an hour, 30 minutes. So if the total that we're trying to find is 15.5 hours, well, we need 15 whole hours, and then we can just add on the 30 minutes in seconds as well. So all we need to do is multiply 3,600 by 15 to get the 15 whole hours in seconds, and then add on the 1,800, which is this extra half hour. So we'll be doing 3,600 times 15, but rather than multiplying so many digits, we could just multiply the 36 by 15 and then put 2 zeros on the end of our answer. So let's do 36 times 15. 6 times 5 is 30, so 0 extra 3. 3 times 5 is 15, add that 3 is 18. Then we've got the 0. 1 6 is 6, 1 3 is 3. Add these together, 0 add 0 is 0, 8 add 6 is 14, so we've got 4 extra 1. 1 add 3 is 4, add 1 is 5. But don't forget that we needed to put the 2 zeros on the end, because actually we wanted to multiply 3,600 by 15. So that means here we've got the number of seconds in 15 hours. And here we've got the number of seconds in half an hour. We just need to add the two. 54,000 add 1,000 is 55,000. And we've got 800 left. So 55,800. And the unit is, of course, seconds. Next question is telling us to find the mean average of 8, 11, 15, and 26. Finding the mean average means that we're adding all of the numbers together, so finding the total of the numbers and then dividing by the number of numbers. So we need to do 8, add 11, add 15, add 26. The total of all of those numbers divided by 4, which is the number of numbers we have. 8 add 15 is 23, and 26 add 11 is 37. 23 add 37 is 60, so that totals 60 on the top as the numerator. For the denominator, we've already got 4, so 60 divided by 4, well, we can cancel the top and the bottom by 4, leaving us with 15 as our average. Question 8, how many thousands are there in 1 million? So how many zeros does 1,000 have? Well, 1,000 has 3 zeros. If we had no zeros, it's just 1. If we have 1 0, then it's 10. If we think about 1 with 2 zeros, then it becomes 100. 1 with 3 zeros becomes 1,000. Now, how many zeros do you need in order to make a number a million? You need 6 zeros. When we have 3 zeros, then this would have been 1,000. So if we've got another 3 zeros here, that means it's 1,000 times as big as 1,000. So there are 1,000 thousands in a million. And we can prove this because we can say if we do 1,000 times 1,000 to check, then 1 times 1 equals 1. And then we just need to add all these zeros on the end, which is 6 zeros. 1, 2, 3, 1, 2, 3. Another way you can think about it is in smaller stages. So we can start with 1. 10 times bigger than that is 10. 10 times bigger than that is 100. 10 times bigger than that is 1,000. You'll notice that every time I'm adding another 0 on the end to multiply this by 10. So what happens if I multiply 1,000 by 10? Then I get 10,000. 4 zeros. Next time I'll have 5 zeros. That's now become 100,000. Then when I have 6 zeros, it will be 1,000,000. Now that this has got 6 zeros, it's actually a million. Question 9 says write down the next fraction in the sequence. We've got 5/8, 10/16, 15/24. What's happening to the numerators? We are adding 5 each time. It's the 5 times table. 5, 10, 15. Next we want 20. And for the denominators, it's the 8 times table. 8, 16, 24, 32. So that would be your answer. But there's something else that we can say about this, which is that actually these are all equivalent fractions. Because if we multiply the numerator and the denominator by the same number, for example, 5/8 becomes 15/24, we're multiplying the 5 by 3 to get to 15, and we're multiplying the 8 by 3 to get to 24. These are actually equivalent fractions. Because let's say we take 15/24. Divide the top and the bottom by the same factor. In this case, we could divide the top and the bottom by 3. If we divide the top 15 by 3, we're left with 5. If we divide the denominator 24 by 3, then we're left with 8. And that is exactly what we started off with. Same goes with 10/16 because I could divide the top and the bottom by 2 and I'd get back to 5/8. Question 10, add 500,000 to 50,000. Well, we had a question not long ago in which we were discussing that a million is 1,000 thousands. Instead of 1,000 thousands, let's think what's half of 1,000? Well, half of 1,000 is 500. So half of a million is 500,000. Because if we doubled that, then you'd get 1,000,000, which is a million. We need to add that to 50,000. And then you can clearly see the answer would be 550,000. Question 11, how much is 3/7 of 196? Of in maths means we are multiplying. So we are doing 3/7 multiplied by 196, which is the same as 196/1. We can cancel the top and the bottom by factors that they have in common. In this case, we can divide 196 by 7. Now, if we don't know that off the top of our head, don't worry. We can use short division. So 196 divided by 7. How many 7s go into 19? Well, 7 2s are 14. We've got a remainder of 5. So how many times is 7 going to 56? Well, 7 times 8 is 56. So that means we can cancel this top and bottom by 7, and we're left with 28 here. So 1/7 of 196 we've seen is 28. If we're trying to work out what 3/7 is, we just need to do 28 times 3. 8 times 3 is 24, so we've got 4 extra 2. 2 times 3 is 6. Add that 2 is 8. Before moving on, we can think, does this sound believable or not? And it does, because 3/7 is less than 3/6. It's less than half. So we want our answer, 3/7 of 196, to be less than half. Half of 196 would have been 98. We were expecting our answer to be a little smaller than 98, so 84 sounds reasonable. Question 12, give all numbers which are factors of both 32 and 24. Factors are the building blocks of numbers. They are the numbers which you can divide the main number by and there will be no remainder. Firstly, let's think of the factors of 32. Well, factors come in pairs, so you can have 1 and 32. You can have 2 and 16. You can't have 3, but you can have 4 times 8. And that's it in terms of the factors of 32. Now let's look at 24. Again, working our way up in pairs, we can say the factors of 24. We've got 1 and 24. We've got 2 and 12. This time you can divide this by 3, so you can have 3 and 8. You can have 4 and 6. And we've reached the middle, so there aren't any other factors here. Now we just need to see which numbers appear in both lists. 1, 2, 4, and 8 appear in both lists. The rest of them only appear in one, but not the other. So 1, 2, 4, and 8. 13, write down a number between 0.3 and 2/5. Well, since the first one is in a decimal form, let's also convert the second one to a decimal form. Well, it's 2/5, which is the same as 4/10, or 0.4. Because 0.4 is 4 out of 10. And if we cancel the top and bottom by 2, then we get 2 and 5. So that means 2/5 is the same as 0.4. We just need to find a number between 0.3 and 0.4. I could say 0.35, for example. The number I choose doesn't have to be halfway, of course. I could have said 0.36. I could have said 0.322. But the main thing is that it has to be bigger than 0.3 and smaller than 0.4. 14. If you are facing south, what is the smaller angle you have to turn through to face northeast? So let's imagine our compass points. The two that we need to look at here are northeast and south. Now, to get from south to east, we have to go through this 90-degree angle here. And to get from east to northeast, anti-clockwise, we have to go through half of 90 degrees over here, which is 45 degrees. In other words, we are turning a total of 90 degrees, add 45 degrees, which is 135 degrees. The reason why I went anti-clockwise here from south to northeast is because it says if you are facing south, what is the smaller angle you have to turn through to face northeast? Because a clock goes clockwise, it might seem natural to think, okay, we're at south, now let's keep going around to northeast. But actually, that angle is the big reflex angle, and that's not the one that we want when they asked for the smaller angle. That's why we went anti-clockwise. Question 15, find 4% of 5,300. Well, what would 1% be? 1% would be 100th, meaning we need to divide this value by 100, which means we can just chop off the 2 zeros on the end. So we can say, well, 1% is £53. So let's double that. 2% is therefore £106. Let's double that again. 4% is £212. 16, if it is minus 26.5 degrees Celsius in Canada and 34.5 degrees Celsius in Australia, what is the difference in temperature? So in Canada, it's minus 26.5. And in Australia, it's a positive number. Instead, it's 34.5. Somewhere in the middle of that is the value of 0. Of course, everything to the left here becomes negative, and everything to the right this way becomes positive. To get from minus 26.5 to 0, we have to add 26.5. And then to get from 0 to 34.5, we of course need to add 34.5, which means that if we add the value of 26.5 degrees to 34.5 degrees, we'll get the overall difference that takes us from positive all the way back to negative. We are actually doing 26.5 add 34.5. 26 add 34 is 60. And then the 0.5 add 0.5 makes 1. So the answer is 61 degrees Celsius. Make sure you write the C at the end, because if you don't, it looks like degrees and angles, which is a different unit. 17, a train leaves Waterloo at 11:35 and arrives in Portsmouth 1 hour and 38 minutes later. When does it arrive? So at Waterloo, it's there at 11:35. And we need to add 1 hour 38 minutes in order to get to Portsmouth. Now, if we add 1 hour, then that takes us to 12:35. Then, of course, we need to add a further 38 minutes. Well, if we add 25 minutes, then we're on to the next hour. But we've got 13 minutes remaining there. So actually, after this will become 13, or in other words, 1:13. Given that I've written this in 24-hour time as they have done, I don't need to write PM on the end of that. 18, what is the smallest number that 2, 3, 6, and 10 will all go into exactly? So imagine if these were denominators of fractions and we were adding fractions and we wanted to find a common denominator, we would need to find a number that all of these go into, ideally the smallest number. Well, 2 is already a factor of 6 and 3 is already a factor of 6 as well. So if we take 6 as a number, we've already got 2 and 3 and 6 covered, because all of these are factors of the number 6. So all we need to do really is to see what's the first number that appears in both the 6 and the 10 times table. That way, the 6 will fit into it, the 10 will also fit into it, and we know if the 6 fits into it, well, so does the 3, and so does the 2. So if we look at our 6 times table, we just need to stop when we find the first number in the 10 times table. We've got 6, 12, 18, 24, 30, and boom, that ends in a 0. That is a multiple of 10, so 30 will work. And it is the smallest because I can go for a bigger number like 60. I could just do 6 times 10, but 30 is smaller than that. There isn't a number smaller than 30 that will work in the same way. 19, give an example of an event which has a probability of about a half. A probability of a half means that we have 2 possible outcomes, that's the denominator, and the numerator is 1, which is the outcome that we are picking, i.e. we need 2 options and we're picking 1, and we need even chance of picking either outcome. A classic example is flipping a coin, because a coin has 2 faces that it can land on. One is called heads and one is called tails. And if you flip the coin loads of times, on average, it should land half the time on heads and half the time on tails. So flipping a coin would be a good example here, as in every case, we're choosing 1 out of 2 outcomes. 1 out of 2 as a fraction is a half. In other words, we've got 50% chance of having that outcome. If we have a scale of 0 to 1, then that would be 0.5. As a fraction, of course, it is just 1 over 2. So let's just say flipping a coin. 20. Find the greatest number of 28p stamps which can be bought for £5. Well, these are in 2 different units. This is in pence and this is in pounds. So first of all, let's bring this into the same unit and say this is the same as 500 pennies. Now we need to see how many lots of 28 pennies goes into 500 pennies. So now we need to do 500 divided by 28. There will be some remainder, of course, if we do this as a long division, but we don't need to worry about the remainder because all it's saying is what is the greatest number of stamps you can buy, i.e. when you divide 500 by 28, what's the whole number? So we can just do this as an improper fraction to cancel it down and make our lives a bit easier. 500 divided by 28, well, what common factors can we see here? You can divide the bottom by 4 and get 7. You can divide the top by 4 and get 125. Now, this is a much easier division to do now. 125 divided by 7. 7 goes once into 12 with a remainder of 5. 7 eighths are 56, but that's too big, so 7 sevens are 49. The whole number which we identified is 17, and the unit is stamps. And that's it for today's paper. So I hope you found that useful. If there are any papers that you would like me to cover, then please do let me know in the comments down below. I will try my best to cover them, and I will see you next time.